Okay, shall we have a little look?
That's what I heard.
Okay, here we go. Let's have a look. So, we're supposed to find dy dx and what's that other thing mean? What's that? Okay. Y double prime, aka second derivative, right? Just a different notation for it. All right, so it's been a little while. How do we approach this? If we're trying to find, and we're gonna go ahead and abbreviate dy dx, we're just gonna let that be y prime and we'll let this be y double prime, right?
Yeah.
So talk me through this. Somebody get us started. What do we know? Okay, we're gonna find the derivative, so like where?
For the equation.
Okay, but I gotta start somewhere.
Product rule.
Okay, good. Okay, so we'll start with the first term. I've got a bunch of different terms here, so we can just differentiate term by term, no big deal. So we've got to do the product rule, okay? So if I do the product rule, I'm going to have the first, so this first term is going to give me the first factor times the derivative of the second. So Janelle, what's going to be the derivative of the second part?
2y prime.
Good. Okay, so I'm going to get x squared times 2y prime. Questions? Okay, plus, now we're not done, right? So there's the first portion of the product rule, second part. Okay, so I get second times derivative of the first, which is 2x, right? Okay, so all that stuff comes from the derivative of just that first term, right? Okay, what about the second term? Yeah, just minus 2, good. Okay. All right, Lucas, what's going to be the derivative of the third term then? Okay, 3y prime, because remember we're differentiating with respect to x. dy dx is y prime.
Wait, how'd you get 0?
Okay, let's backtrack a little bit. Okay, shh. Y'all settled in, Riley? Okay, good. All right, so all this stuff right here came from the derivative of the first term. The derivative of minus 2x is just minus 2, right? Okay. Then we get our plus 3y prime. Derivative of 10 is 0. Okay. So now, the first part, all we have to do here, and notice, let me just remind you, it's been a while, that whenever we differentiate implicitly, and that's what we call this, right? Implicit differentiation. We're not explicitly solving for y, we're just taking it as it is and differentiating, right? When we do that, the nice thing about this is the product rule, or excuse me, the chain rule, which, you know, I know maybe it's at first was a little tough, but you're getting better. The chain rule does something really nice here. Every time we have a y in a term, we always end up getting out just a y prime to the first power. Right? And so really the algebra ends up being pretty simple. All we have to do to isolate y primes the same every time. We're just going to, get the y prime terms on one side, get the non-y prime terms on the other side, factor away a y prime, and divide by both sides by the remainder, right? Every time it's the same, okay? So do we want to go through all the steps or do we want to challenge ourselves to be, let's see if we can skip some steps here, how about it? All right. So we'll leave space to add, we can add the steps if we need to later, but let's think about this now. If I get all the y primes, the y prime terms on one side, right?
Yeah.
The other terms on the other side, would you agree those are going to end up being the numerator of the fraction that we're left with, right? Okay, so then on the other side, our numerator is going to be what?
Negative minus squared minus y squared minus plus 2.
Okay, so negative 2x y squared plus 2. If I add that, right? Does that make sense?
Yeah.
Okay, so then those guys, let's keep track. These ones are accounted for. We push those to the other side. Okay, the non-y prime terms are already all on the left side, aren't they? Okay, so when I factor a y prime out, whatever is left over, the other factor that's left over is going to become the denominator, right? So then over here we've got our, got our y prime. And so the denominator is gonna be what?
X squared 2y plus 3.
Okay, good. Right, if I factor the y prime out of that one, I'm left with x squared 2y. In other words, 2x squared y maybe, right? Put the number out front. And then this guy here, we're gonna be left with plus 3. So there's the answer to part 1, right?
Yeah.
Okay. Now the answer to part 2, this is where it gets a little ugly, right? When we want to do a second derivative here.
But just grab the one above.
Okay, good, we could, couldn't we? We don't really have to, we don't really have to do this. We don't really have to take this big quotient rule here and differentiate that if we don't want to. We could just go back to the preceding step and just implicitly differentiate again. You know, to me, I prefer that just because I'd rather not do the quotient rule if I could avoid it. Okay, so we'll go back up here. See if I can just, can I not get rid of that guy? Come on. There we go. Okay, so let's go from here. How about if we, just to kind of clean things up a little bit, why don't we rewrite those just a little bit?
Yeah.
Let's put the, put the 2's out front, things like that, right? So we end up with 2x squared y prime plus 2x y squared minus 2 plus 3y prime equals 0. Okay, go. How do we deal with the first term here when we're going to differentiate?
We don't use the end result of the last one.
Well, I mean, we could, that's fine.
Or we don't feel like
We don't feel like it. I mean, do you see, let's go back for just a second. Okay, the question is, why don't we just use this end result? We can, but let's just kind of think ahead a little bit here about what's going to happen if we do that. The advantage is, and there is an advantage, the advantage is if I differentiate this one directly, I'm going to get a y double prime equals some answer, right? Think about that answer though. Inside that answer, we've now got a quotient of polynomials, each of which involve product rules, right? That's kind of ugly. I mean, to me, I don't know if it even ends up being any different in terms of the actual algebra that you do, but just at least conceptually to me, it always ends up being a little easier to just think of it this way. Okay, to just go from there. We are, however, and Ryan makes a good point here. I think, maybe he's getting at this. We are going to have to substitute anyway, aren't we? Right? We are eventually going to have to substitute wherever we get y primes. There's our y prime, right? Okay. So first term, talk to me about some things some suggestions. Let's not try to take this all at once. How can we make this as easy as we can? Oh, good. Pull the 2 out front. Very good. 2 out front. Well, no, we can't, but on that first term we could, right? On that first term, we could take this 2 and just pull that out front, and then we're going to have a bunch of stuff that we get from differentiating this big old product.
Yep. Could you take out 2y?
We can't really take out a 2y prime, and the problem with that is, if we take out a 2, well, because the y prime is going to be part of, you know what I mean? That's part of the product rule.
I mean, I'm just thinking like, if you do like x squared times y, like that, and then do this product rule with y prime.
You could. Yeah, we could. So here's another question, and I don't know if we've ever done one exactly like this before, but how do we deal with that product, right? This stuff right here. How many factors are there in that product? Yeah, there are 3. Now, there's a number of ways we could do this, but let's talk about it. Well, I mean, what's one thing we could do? Okay, good. We could group it together. We could say something like x squared times y is going to be one product, right? Or one factor, and then the other factor is y prime. And when we differentiate the first, then I have to use the product rule, right? Does that make sense? That would be fine. There is an extended product rule though, it's not a big deal. It's exactly what you think it is. What do you think the extended product rule is? If I have something like this, for example, if I have the derivative with respect to x of u v w, what do you think it is? We used to say first times derivative of the second plus second times derivative of the first. What do you think this one's going to be? U v w prime plus u w v prime plus v w u prime. Okay. No, actually, it's to me that's a little bit easier to do, but either way, let's just show real quick that that's the same thing as saying what if we group these two?
Could you do?
What if we group those two and just do a regular product rule? So if I do a regular product rule, I'm going to get first times derivative of the second, right? So uv times w prime plus second times derivative of the first. Well, what's the derivative of the first? That's the derivative of u times v. So that's good. U v prime plus v. Isn't that when all the dust settles, if I distribute that w, isn't that just that?
Yeah.
Okay. So that's probably good to be familiar with. Usually you don't see that in like a first year calculus class, but it's honestly easier just to extend that, just to, it's the same idea, the same pattern, isn't it? Right? The extended product rule is the same as the product rule.
I mean, is there any reason you have to move those primes to the end?
No, there's not.
Just move the prime.
Yeah, I think in books it's half of one, 6 of one, half a dozen of the other. It's not, however you want to do it, doesn't make a difference. You just know that you're differentiating those one factor at a time. So you could, if I had the product of 10 things, I mean, you would know what the extended product rule would be, right? I mean, it would just be kind of ugly, but it's a lot easier than having to go through this whole process, really, isn't it? I mean, if you get that many. Okay, so let's use the extended product rule and do this one then.
Wait, so hang on a second.
Yep.
What are we doing? Go back.
That slide. Okay, so we're differentiating we took the first derivative and we got some y prime stuck in there, and now we're going to try to find y double prime. And so we're just going to implicitly differentiate again, right? And then some y double primes are going to pop out.
Yep, we're not, okay.
Does that make sense? Okay. So in the first one, suggestion was made to just pull the two out front so we don't have to deal with it the whole time. We'll redistribute it later. Okay. Using our extended product rule, what are we going to get? So x squared times y times y double prime is the first part, right? Okay, plus next term. X squared, okay, yeah, x squared times y prime, which is the same thing as y prime squared. Is everybody okay with that?
No, I'm sorry, I don't.
Okay, let's see that again.
Y prime times y prime is y prime squared.
So the first time through, we differentiated the third factor. Second time through, we differentiated the second factor, but y prime times y prime is just y prime squared.
Okay.
Okay?
Yeah.
Plus, now we're going to differentiate the first factor. Good. Okay, so I'm just going to get 2x times y prime, right? So that's the derivative, all this stuff is the derivative of just that stuff in the green, right?
That's crazy.
It's crazy, I agree. Okay, plus, we just keep going. But now, this is gonna look, think of it this way, think how impressed somebody would be if they walked in here and they just saw, look at this, this is.
I love
And-
Until they say they can use them on our faces, they're like,
I don't.
But really, now, differentiation, remember, we're just following rules, that's all we're doing, right? This looks horrible, but it's not that bad, we just keep going, keep plugging away, don't lose heart. Okay, next step, we gotta differentiate that one.
Okay,
Yeah.
so 2
Times,
x squared, and then is it y prime? Wait.
okay, focus please. Okay, so if we're gonna we pulled the 2 out front, so we're just differentiating the product of x and y squared.
X 2y.
X 2y.
Y prime.
Good. Plus y squared times 1. Minus 2
0. No.
goes away, right? And we differentiate. And then plus 3y prime. Good. Equals 0. Good. Okay, so let's just cop out a little bit on this one.
whoa, wait. So it's 3y prime.
Y double prime.
Okay.
Everybody agree? Because the derivative of y prime is y double prime? Okay?
Yeah.
So then now we got to distribute the 2's. Let's go ahead and write this out. There's just a lot going on here. So we get 2 x squared y double prime plus 2, oops, it's supposed to be, I'm just going to make the y double primes red. Plus 2x squared y prime squared plus 2xy y prime 4. Good.
Just for simple multiplication.
Plus, so we're done with those guys, now we're over to here, plus 4 x y prime, can't teach an old dog new tricks, I guess, plus 2y squared plus 6.
Whoa, we don't do that.
No,
it's 3. It's just 3.
It's just fun.
Oh, you're right. Maybe you can't teach an old dog new tricks, I don't know. Plus 3.
Alright.
Okay, so then all we have to do is just, pull the y primes on the left, subtract everything else to the right, divide by what's left over. Okay, now, would you agree, let's agree on cheating just a little bit on this. So when we're done, would you agree that we're gonna get y prime in terms of x's and y's and y primes? Okay, so we could if we wanted to, we could go back and plug in that every place for y prime. But just for the, you don't want me to develop carpal tunnel, so we're not gonna do that.
If we're on,
We could.
if we're on the test, we have to do that.
On a problem this big, no way, I would make it.
So we just have to put y double prime.
Yeah.
Yeah, would you indicate in terms of y, x, and y prime to tell us?
Yeah, right, exactly, yeah. Very good, you're right. Okay, so what's the answer gonna be then? Now this you can do. Shh, come on now, let's go. What do we got? What's gonna be the numerator of the other side?
Negative 2x y prime squared.
2x squared
2x squared.
y prime squared minus,
8x.
oh, those are the same, oh yeah, look at that. Oh, look there.
Oh, that is so cool.
Like terms, how about that?
Yeah.
8x
Minus 2y squared. Because we're chasing all those to the right, correct? And then what we're left with, so all those guys are gonna be gone. And then we're just left with those two terms, factor out a y prime, and what's left? that, exactly.
That plus 3.
Plus, yeah, that's fine, we'll leave this as the answer.
Yeah. We're done.
Okay? Fair enough?
And then
Plug in Wi-Fi.
But we won't. We
We're
won't.
supposed to do that? No.
Okay.
No.
We gotta do exact. I need to see it with Y prime.
I think we should plug in Wi-Fi.
No, that's.
I'm scared.
Y prime.
Okay,
Cinco Viejo. Good job. Nice. Good job. I don't know.
Oh, no, you wouldn't. You wouldn't have to. It's not different. Just like, at least it had Wi-Fi with the Wi-Fi on the bottom. That would.
oh, here's a good one.
Or what?
Okay. Okay, how about that? Now, what you gotta do, let me remind you here, on these, don't panic. Take a few deep breaths, and don't jump into it. Just kind of think about what the,
Dip your toes in.
yeah, dip your toes in, there you go. Just think about what the prescribed calculus is gonna be. What does this mean? I mean, this means, okay, it has to do with slopes, doesn't it? Because horizontal means slope of 0.
Tangent line.
Vertical means slope of, like, infinity, right? Undefined. Okay, so then all we're really doing, what does slope mean in terms of calculus? Derivative. Yeah, first derivative, right? So all we're gonna do is solve for y prime, and then whatever the result is, we're either gonna find out when that result is equal to 0 or when it's equal to infinity. That sounds a little weird, but it won't. You just watch. So this isn't that much easier problem, honestly. So if we differentiate this term by term, what do I get for the first term?
50x.
50x, good. Okay, so we get 50x plus 32y prime. Keep going.
Oh.
Plus 200
Minus 160y
Oh, 0.
0.
equals 0, right? Good. Okay, so let's isolate the y prime. So y prime equals, what's on the numerator, in the numerator? Divided by,
All of 32 minus 160.
okay, so now I've got some pointed questions for you.
Uh-oh.
Okay, so if I have this is called a rational function, right? Only it's in different, yet x is on the top and y is on the bottom. So when is a ratio or a fraction equal to 0? Say it again. What? No. When is the fraction equal to 0?
Numerator 0.
Numerator 0, right? Because, for example, 0 divided by, you pick a number, is 0. Okay, right? So then, this is big. This looks really simple, but I want you to see the thinking that goes behind this. We use this a lot in math and physics. So from this, we can build a simpler equation to solve, right? We could say that y prime equals 0 when negative 50x minus 200 equals 0, correct?
Okay.
You see my thinking?
Yep.
Okay, because Because this is the expression that's in the numerator, and you just told me that when the numerator is 0, the fraction is 0, right?
Yeah.
So we get to trade these here a much, much easier equation, right? That's the mathematical word for it. So this is an easy one to solve. What do we get for an answer?
-4.
Yeah, we could just add 200, divide by -50, so x equals -4. That's where what happens. Okay, so
So is that
what kind of
horizontal?
horizontal? Good. So the horizontal tangents occur at x equals -4, right?
Yeah.
Okay.
Okay.
You would, but horizontal tangents is a 0 derivative, right? So these are, so horizontal tangents. Okay, so now,
How do we find vertical?
okay, when the bottom, right, very good. Okay,
Can you substitute X?
there you go. So now for a fraction, when is a fraction undefined?
0.
When the bottom is 0 and the top is not, right?
Yeah.
Okay, so y prime equals infinity, or it's undefined, however, whatever you want to say, when 32y minus 160 equals 0, so y equals 5. Okay, that's where we're going to get vertical tangents, correct? Okay, but we're not quite done yet. Alexis, you can thank her for this. She caught this. I didn't ask for x and y values. I asked for points, didn't I?
You
Right.
did.
I did.
So you just put it back and add those.
Yeah. Okay, so if we want to know what the corresponding y value is when x equals -4, what are we going to do?
Plug it in.
Plug it in. Okay. Okay, so what do we get? What do we get? So if I plug in -4, what's the first term going to become? 25 times 16, so that's going to be 250 plus 150 is 400, right? Plus 200 times -4 is minus 800.
Oh, it's correct. Dang it.
You tried.
Okay, well look at this.
Wait, did you rip it off or did you
Is that light? Has that always been there?
No.
Oh my gosh.